in theory, this stuff that we're doing today should be all reviewed. Now, I know that some of this stuff may be rusty and maybe completing a square for a lot of you you've never even seen before. Okay, so you got to make sure you ask questions and you understand how each method works. Okay, all right. So anytime we have a quadratic equation, that just means we have an x squared as our leading or as our highest exponent. In general, it's always a good idea to make sure things are set equal to 0 first. Okay, like for example, you wouldn't try solving this by square rooting both sides. You can't do that because you have an x squared there and an x there, and you can't square root it. Okay, so first we're going to move things around and write it in the usual format. Oh, and I screwed up already. What should that have been? -48. Yes. Okay, and now you're going to have a couple of options. Okay, since this one is telling us that we can factor, okay, that's going to be your primary approach. And I'm going to show you what I think is the easiest way to do it. Okay, some of you may have like a method where you take 25 times 16, you get 400, and then try to split up that to figure, you know what I'm talking about, with the split in the middle, I think it was called. Okay, you can do things that way, but I'm telling you a lot of the time it's going to be pretty easy to factor just by guess and check. Okay, and for something like this, especially when you have a square at the beginning and a square at the end, do you guys know what I mean by that?
Yeah.
What multiplies the 25x squared, the most obvious ones?
5x.
5x and 5x. In other words, the square root of those two. Does that make sense? How do I get 16? 4 times 4. Okay. And now the way we would check to see if this is correct or not, obviously you can just multiply it all out. And some of you do that on your work. I like to just kind of connect the outer and the inner terms. Okay. If I multiply the outsides, what does that multiply to? 20x. What about the insides? 20x. So we're going to get 40 or negative 40, depending on how we arrange the pluses and minuses. Does that make sense? If I make both of these negative, now these are actually minus 20 and minus 20, which is exactly what we want, and it multiplies to positive 16 still. Does that make sense? So we've essentially just guessed, we got it, we're good. And we avoided that whole split in the middle and writing out like 5 or 6 steps to get there. Okay? Now, later on, if you guys want me to review split in the middle, I can show you that method as well. Question? Okay. Once you have everything factored, now you take each factor and set it equal to 0. Now, in this case, they're both the same factor, but now you would just solve for x, and you get x equals 4/5. Okay? This look familiar?
Yeah.
No one's like, I've never seen.
Yes.
Okay. Square root method. Okay, so that's the next one. This is used when there's only literally a single variable, meaning it's not a z squared and a z. See what I mean here? We have an x squared and an x. If it's just one single z, we should be able to move stuff around and get it alone. So it's a little different than these. Okay, so first, I'm going to write this down. You want to make sure that the square is alone, which in this case it is. Okay? How do I undo this whole thing being squared? Square root both sides. The square and the square root cancel out, and you just get 3z minus 2. And now remember, when we square root both sides, we get plus or minus 2 on the right-hand side. Okay, you should always expect 2 answers, unless it's a problem like above where, you know, it's the same factor twice. But that's a good way to remember that plus or minus when we square root both sides. So now you would do each case. Okay? Let me finish solving for z, though. So if I add 2 to the other side, and then divide by 3, this tells me how to get my 2 answers. One answer is to do 2 plus 2, which is 4 over 3. The other answer is to do 2 minus 2, which is 0. 0 divided by 3 is 0. Okay? Do you guys see how we're getting those two?
Wait.
Yes.
Oh, never mind.
You sure?
Yeah.
Okay. Any questions so far? So if we factor, we use the zero product property. You set each factor equal to 0 and you solve. Okay?
I don't have a task. Shit, I'm not going for that. Just one balance. For that one. What? Hey, did you say that?
Okay, sorry about that. So, any questions so far? Okay, we're going to skip completing the square for now. Not because we're not going to do it, it's just this is going to take us a little bit of time. These other two should be pretty easy. Okay, quadratic formula. Okay, here it is in case you forgot it. Some of you probably know that song that helps you remember it. Okay.
Wait, what was it?
Sing it, please.
No, we don't want to sing it, especially not on YouTube. But you know, it goes to the tune of what is it? Pop Goes the Weasel or whatever.
I don't remember it.
Okay. Claire remembers it. You can ask her to sing it for you if you want later.
It would jog my memory if you could sing it for me.
Anyway, when you're using the quadratic formula, okay, for the most part, just like with the first method, you always want things to be equal to 0. Okay, so I'm just going to do this first one. So move everything to the left-hand side. So 2x squared plus 2x minus 1. Now it's set equal to 0. And you're not going to do this every step, but I'm going to since it's the first one we're reviewing. I want to write down what A, what B, and what C are so I have those in front of me. What's A? What's B? And C? Okay. So these are the three values that you're going to use. And we just run the quadratic formula. Again, that shouldn't be new to you. So we're just going to cruise through this. We get opposite of B, so that's -2, plus or minus the square root. B squared is going to become 4. Minus 4 times A is 2. C is -1. And that's all divided by 2 times A, which is also 2. Okay? Just make sure you plug everything in correctly, and then you just do the math. Okay? In the square root, what's 4 minus 4 times 2 times -1 going to turn into?
8. Actually, 12.
12. This part is 8. Still got to add the 4, but yeah, so we get 12. And then 2 times 2 on the bottom is 4. Okay? And then now we're going to reduce the radical. -2 plus or minus, what is the square root of 12 reduced to if you... 2 root 3. Very good. Almost there. Okay. Now I'm going to show you what I think is the easiest approach to always reducing your answer. There's always, when you use the quadratic formula, 3 parts, 3 terms. Okay? If you look at the leading number, the number right in front of the radical, and the denominator, all 3 of those, is there anything in common to all 3 of those? What number? So if we're going to reduce this, a short way of doing this would be to divide every single one of these by 2. So this is going to become -1. 2 divided by 2 is 1, so it's 1 root 3. In other words, just root 3. And then 4 divided by 2 is 2. Okay? So this would be your reduced answer, like on an exam or a quiz. I will take this. On Math Lab, you might have to actually write them out, like -1 plus radical 3 over 2, and then -1 minus, and split them up. But this is acceptable. Okay? Any questions on that? Okay. I'm not going to do this example because you have one and that's really all you need. I will say one thing though. If they're asking you to use the quadratic formula and you see fractions, I would first, so for this one, clear the fractions. In other words, if I'm dividing by 4, you see how that's over 4, that's over 4, and that's over 2, right? There's one number that I could multiply by that will cancel out all those numbers. What could I multiply by so there's no more fractions at all?
4.
Very
No,
good.
2.
No, you're right. If you do 2, that'll cancel out this one,
Oh, yeah.
but then this is still going to be a fraction, and so is that. 4, however, multiplying everything by 4, what does that leave you with on the left-hand side?
3x squared
3x squared
minus 1
minus 1x, and then 4 times a half.
2.
And then now I would run the quadratic formula with a nice number. You know, I wouldn't use, I mean, you're not going to get it wrong. It's just tedious to have all those fractions in there. This is a much easier to deal with.
Hey, good expression.
Yeah. Okay. Any questions so far? Calculator time. Okay. So if you're asked to just find approximations, the calculator is a great method because you can save yourself the hassle of quadratic formula or making a little mistake here or there, okay? And it's pretty straightforward to do. First, like all the other ones, make sure that it's equal to 0, okay? And now what we're going to do is type in the left-hand side. We're going to put that into y1, okay? So go ahead and go to the y equals menu. And type in x squared plus the square root of 2 times x. Make sure that the x is outside of the square root. See how it's not on the inside there? So make sure that you arrow over so that it's not in the radical here. Minus 2. And now we hit graph. And there's our parabola. Okay? Now, on the right-hand side, it's equal to 0. Okay? Keep that in mind. It's equal to 0. What's that menu we've been using a lot lately after we graph? Second trace. What option here would make sense, keeping in mind that we want this thing to equal 0?
I can say 0.
0 seems like a pretty reasonable thing to do, right? Have we seen this before? Okay. Now, just to make sure, the solutions are right there on the x-axis. Does that make sense?
Yes.
That's what we're trying to find when it's equal to 0. So when it says left bound, just arrow over and make sure you are to the left of that first x-intercept. Okay? Right bound, same thing. And if you've done things correctly, one time you would be above, one time you would be below the x-axis. Okay? And now for the guess, you could just enter a third time. And there it is. There's one of our answers. Approximately -2.29 if I do 2 decimals. Okay? Take 10 seconds, find the other one. What are we getting? 0.87. Okay? Again, if you aren't not getting that, second trace, 0. Make sure you're to the left of that x-intercept right there, which I am. And then get to the right, and there it is, 0.87. Okay? Any questions on how to use the calculator to find the solutions to a quadratic when it's equal to 0? How many of you have seen every single one of these at some point? How many of you probably have but aren't, probably just forgot? Okay. Does it make sense though?
Yes.
Okay. Before we do completing the square, the one thing that I'm going to mention, okay, this right here. In the year previous, we spent probably about 3 weeks factoring. Just factoring and getting really good at it. We didn't have that luxury this time around. Some of you did some practice, when I said here's some problems that you can try on MathLab, or it wasn't MathLab, it was a different site. But it's very important that you guys are good at factoring. So if you're doing MathLab and you're asked to factor and you're spending 20 minutes trying to figure out how to factor something, you're missing some major details. Okay, I would not expect you to relearn on your own if need be. Come in and see me and I can review some methods with you one-on-one or in class when we have time. Does that make sense? Okay, but you need to know how to factor pretty well. Now, as far as this last method is concerned, completing the square, I'm going to do a simpler example first because this one's actually pretty tricky to do completing the square with. So let's go over here and let's say I have x squared plus 6x minus 4 equal to 0.
Is this for square root method? Or
This is for completing the square.
Oh, okay.
Complete the square. Okay. So completing the square is the process of turning this into something like this, where it's something squared on one side. Okay, that's the point of it. The problem is that currently you can't do this. You have to actually add something first to get it to factor that way. And so here's what I would recommend. Yeah, first we're going to add 4. But I'm actually going to leave a spot on the left-hand side because we're going to fill in what this number needs to be so that it factors perfectly. And if I add a number to the left, I'm going to have to do the same thing on the right-hand side. Okay, you can't just put a number on one side and then not do anything to the other. You got to do the same thing on both sides, right? Now, let's see if you guys can figure this out. When you're factoring, typically you look at this last number and try to find numbers that multiply to this and add up to that number, right? Now, if we're completing the square, we want this number to be a square. Does that make sense? Another way to think about it is that this gets split into 2 equal numbers. So even if you don't know, what 2 numbers add up to 6? 2 and 3, we want the same number. 3 and 3 add up to 6.
Oh.
Does that make sense? I'm sure that's what you meant.
Yeah.
Okay. What's 3 times 3? So 9 is the missing number here. I'll explain a good way to just do it, because eventually you just want to know what to do, not think about it. If I add 9 on the left, we're going to add 9 on the right. Okay? Now the whole point of adding this 9 there is that this is going to factor as x plus 3 times x plus 3. We made it that way. Does that make sense? So this is going to become x plus 3 squared. And then on the right-hand side, we got 13 now. So now I've taken this equation and turned it into the square root method, essentially. See what I'm saying? Now we can square root both sides like we did in the previous box.
13 doesn't square root.
What's that?
What if 13 doesn't square root? Like, even
As long as it's positive or 0, we get a square. Oh, you mean like perfect? That's okay. We're just going to leave it then. So x plus 3 equals plus or minus the square root of 13. You're right. We can't reduce it, and it's not a nice number, so we leave it as root 13. What's the final step here to get x alone? Subtract 3. So it'd be negative 3 plus or minus the square root of 13. These would be the two answers. Okay? That's completing the square. How many of you have not seen that before? Okay. Majority. That's kind of what I thought. So let's recap. Okay, number 1, make sure it's just x squared at the beginning. That's number 1. Okay. Number 2, let's see if we can figure out how we got this 9 in words. How did we get 3 from the 6? You guys remember how we got the 3? Like,
You add
how would I get 3 looking at the 6?
add through first.
the two numbers that add together
tree.
to the middle number.
Two numbers that add up to the middle number.
And multiply.
Okay, let's.
Oh, so that's reverse.
It's backwards. What if this were a 10? What would it be?
9 and 1.
Has to be the same number. 5 and 5. What if this were a 20?
And 10.
10 and 10. What's the relationship between this number and this number here?
Half of the number.
It's always half. 20 becomes 10 and 10. Does that make sense?
What if it's not an even number?
We still can technically divide it by 2. It's just going to be a hot mess. Like if it were a 7, it's going to be 3.5 and 3.5.
That's why you did it, because this one would be 1.5.
Yep, this one's going to be a hot mess. Okay. So you guys said take half of the middle number, right? So do half of b. You guys know what I mean by b, right? The number in front of the x. And then how did we get the 9? We squared it. To find what to add on each side. Okay, so using the easier example, first I make sure that it's just x squared at the beginning, which this is. Next I take half of the middle number, which is 3, square it, and I'm going to add 9 on the left. And I'm also going to add 9 on the right. You can't just add and then not adjust the other side. After doing that, this becomes a perfect square factor. And then that allows you to square root both sides and solve like usual. Okay? Do you guys want to do another easier example like this before we get to this tough one? You just rather do the tough one? Okay, yeah.
For the top one, since the middle number is -3, would we have to like take out negative from all the numbers?
No, you can still keep it there.
It would just be one of them in positive.
The only difference is right here. Instead of a positive, it'll be negative.
Because both of them would have to
Both of them will have to be negative. Exactly. Good question. Okay, so let's see if we can do the hard one. First, okay, this is not just x squared, right? How could I get rid of this 2? Divide by 2. Very good. So x squared, and we have calculators available this unit, so I'm just going to make life easy for us. And I mean, I know what this is, but you might as well just use the calculator, okay, and then convert it to a fraction. You're going to get negative 3 over 2x.
Do you think it would be easier to keep it in like a fraction or?
Definitely, especially as, like for writing your final answer, yes. So let's say I did not know that this is going to be 3 over 2, like maybe it was 63 divided by 7, and I wasn't sure, oh, shoot. What if it was like 63 divided by 10, and I wasn't sure if this reduced to a different fraction? Do you guys know how to do math fraction on here?
Yeah.
Okay, so that's kind of what I'm expecting you to do, okay? Oh, that's the school calling. Should I listen?
Yeah.
Congrats.
An important message from Township High School District 214. To hear the message now, press 1. To place the call
9.
on hold, press the pound key.
Oh, did it say 1?
Sharon Brooks, Assistant Director of Community Engagement for District 214. Due to predicted extreme weather, the district will be making a number of modifications to our schedule this week. Please listen closely to the following closings and cancellations and note the work schedules at the end of the voicemail. For today, Tuesday, January 29th, 2019, all after-school activities are canceled except varsity level contests completed before 6:30 p.m. or for teams in the state tournament series or IHSA-sponsored state tournament series, where failure to attend would result in our students being disqualified. The young adult program and community education classes are canceled. All District 214 schools will be closed Wednesday and Thursday, January 30th and 31st, 2019. All after-school activities and programs are canceled for Wednesday. Buildings will reopen at 2 p.m. Thursday for after-school activities and parent-teacher conferences. The young adult program and community education classes
Okay,
are
that's really all you
canceled
need to
for
do.
Wednesday and Thursday.
So that's cool for us.
You really like to hear that.
Okay, sorry YouTube, we were kind of waiting for that. Oh, I gotta text my wife back. She was just asking. Yep. Now go ahead.
I know.
Okay. So here we are with the tough example. So we moved the 1 over. Oh, I made a mistake. What should this be? Yes. We divided by 2 at the beginning, and this should be a 1/2 then, when I move it to the right-hand side. Okay? Now we're going to try to follow very slowly the exact same steps that we did over here. So we took half of 6 to get that number, right? So I'm going to do the same thing. -3 divided by 2 times a half. Okay, I don't even have to worry about the fraction yet. And then once I figured out that it was 3, how did I get this 9? We squared it. So I'm going to square whatever that is. Okay? But now here's why we do math frac. And now we get 9/16. And then we also have to add 9/16 on the right-hand side. Okay? Let me stop there and make sure everybody's good. Because this, it looks tame, but once you start doing the method, it gets pretty involved with the fractions.
I feel like just like moving the stuff over and leaving the spaces blank is just nice.
It is, yeah. Okay, so now this on the left-hand side, we designed it so it turns into a nice factor, right? Now it's going to be x. This was a minus in the middle, so this is going to be minus. And then keep in mind, this 3 was half of 6, right? So whatever this number is going to be half of the 3/2. And I think somebody said it earlier, but it should be 3/4. Okay? You could also do it this way, just square root this number over here. Okay? Square root of 9 is 3. The square root of 9 and the square root of 16 is 3/4. Okay? So that's how you can remember what to fill in there. Okay? On the right-hand side, you can either do it by hand or on the calculator. 1/2 plus 9/16. 17/16. Okay? You guys with it so far? What's next? Square root both sides.
Wouldn't you want to square root the
We square root everything. Everything gets square
For
rooted.
the fraction, 17 over 16.
So hold on one sec. On the left-hand side, we get just x minus 3/4. On the right-hand side, and I think this is what you were asking about, the square root of 17, do we know it? Jared's like, yeah.
Yeah.
What's the square root of 17? Without putting it in the calculator.
Oh, I don't know.
Yeah, we don't know it. Can we reduce it?
Yeah.
4
No, without a calculator. Like, is it 2 root 5? Is it 3 root?
I don't think.
Oh,
It doesn't reduce, right? So we leave it as root 17. What's the square root of 16, though?
4.
So we're going to leave that as 4 now, and don't forget the plus or minus. And then we have one last step to do. How do I get rid of the minus 3/4? Add it to the other side. So the final answer is 3 over 4 plus or minus the square root of 17 over 4. Okay? This is new for a lot of you, completing the square method, but you do need to know how to do it. Okay? Every single method on this sheet you have to be comfortable with, because on the quiz, or I don't know if we'll even have time for a quiz this unit, but on the test, it will tell you, solve this by factoring, solve this by quadratic formula, solve this by completing the square. So you got to be able to illustrate that you understand all these methods. Does that make sense? Any questions?